In this demonstration, I would like to find the intersection of the parabola, which is the blue curve, and a circle. And they are represented by the equations. F of x1, x2, it is the parabola equation. And g of x1, x2, it is to represent the circle. In Newton method, we start with an initial approximation, which is x vector at kth iteration. Then we compute the Jacobi matrix, which is in this case represented by elements -4, 2 times x2, 2 times x1, and 2 times x2. And then, okay, in this equation, this Jacobi matrix is multiplied to the function values evaluated at the old approximation. So I start the algorithm. Spotlight. Okay. So I write here, this is x old. And then I define here a matrix. This will be a 2 by 2 matrix. I call it J matrix. And I have to then calculate the J inverse matrix. It will be of consistent size. JINV. JINV. Then I will multiply J inverse and F. So let's reserve something for the calculation of F of X. Then the new value of X will be calculated. And then I will calculate the error in iteration. Right. So this is that's how the algorithm is going to look like. These are the steps. Let's follow this strategy. So I define x old. I take 0, 0. So this is true that it is for x1 and this is for x2. Okay. Then J matrix to be calculated. So it is equal to 4. First element is 4. Then it is 2 times x2. So it should be taken from here. Then this one is 2 times x1. Okay. And then 2 times x2. The matrix has been calculated. Now for J inverse, it's a 2 by 2 matrix. So its inverse should have the same size. In Microsoft Excel, there are few functions available for matrix, like matrix multiplication and matrix inverse. And it is implemented like you have to first reserve the cells for calculations, then provide the equal sign, and then the matrix inverse function. And then you have to pick up the elements of matrix. This is done. And then the special way of pressing the enter, not just the ordinary enter. You have to press Control, Shift, and enter. We got nothing. Let me check if I provide 1, 1. Okay, so matrix inverses have problems with the data, right? And just to confirm whether it was a correct calculation, I reserve 4 cells. I reserve these cells and then apply the matrix multiplication. Matrix multiplication at the first array from J and J inverse. So hopefully, if it is correct, then it should return an identity matrix. So very much correct. So whenever you find inverse in some algorithm, be careful, inverse of a matrix, then be careful that it is going to crash if the matrix is singular, right? So criteria for the selection of initial guess. Earlier in the fixed point iteration, we were allowed to start with the 0, 0. But this method has crashed because of the inverse property. Okay, now let's move forward. Okay, we have tested the functions. That's the essence of these demonstration. Okay, then f of x. So from the first equation, x2 squared minus 4 times x1. This is fine. And then the second function, it is equal to x1 squared plus x2 squared minus 1, and that's it. Now let's compute x new. So x new requires xk minus j inverse times f of xk. Right. So I calculate, since I'm using Microsoft Excel, so I first calculate the product, j inverse and f. Okay. Since I'm going to use the function, so I would like to write it clearly. So here, the multiplication. So a matrix multiplied to a vector, it is going to have a shape of a vector, right? So I reserve the two cells in column shape, and I write here matrix multiplication. The first array is J inverse, and the second array is the function. Okay. So let's do it again, because I think I have violated the procedure. Matrix multiplication, the selection of first array, J inverse times the second array, which is a vector, and then Control Shift and enter. Okay. Now it's time to calculate x new. We have xk, j inverse f of xk computed as a product. So x new. So x new is x old minus the corresponding value in product j inverse f of xk. So it is this one, and the second one will be like this, right? So corresponding values, right? We know by the meaning of vector sum, it is applicable on element by element basis. Now the error, so the error must be computed. X new value, I use the second order norm, so which is like distance formula SQRT of this value, new value in the first element, the old value in the first element and square of it, plus the second element in new vector minus the second element in the old vector and square of it, and that's it. So we got the error 3.202. Now for the next iteration, you have to start with the new value. So I cannot do the dragging. I will only do the copying and pasting. So I copy the new value, copy from here, and I will do the option of paste special with the option of values. So it seems the error is exploding. So let's start with the improved with some different approximation like 0, 1. Okay. If I start with 0, 1, then the new value is minus 0.025. Okay. And this is 1. Now I take this new value, copy and paste values. Point 0.25. It has increased. One more time. 0.85. So it is on the track of divergence. It is on the track of divergence. One more initial approximation. So nonlinear problems require patience to get to the solution. 0, 1. Did I started with 0, 1 earlier? Oh, I started with 0, 1. So now I start with 0 and 0.5. So the error 4.96. Let's see whether this track has some hope for us or not. No hope. So I leave this step further exploration for students. The procedure have been demonstrated. Procedure has been demonstrated. So that's more than enough. Let's stop at this point.